What Our Survey Really Says, a statistics project by Izzy Millott. Hi, I'm Isabella Millott, and this is my final project for statistics class. In this video, I'm going to walk you through a project where I used real survey data from our class to explore how students live, learn, and relax. We collected answers about things like how much students sleep and study, whether they drink coffee, and what kind of music they like, and their favorite school subjects. I used StatCrunch to organize the data, clean it up, and run several types of analysis. You'll see the histogram, pie charts, box plots, scatter plots, confidence intervals, a hypothesis test, and a correlation. The goal of this project was to apply everything we've learned this quarter to real data and draw conclusions based on evidence, not just guesses. So let's get started. So the introduction. What was the purpose? The main purpose of this project is to apply statistical tools to the real world data. Throughout the quarter, we learn how to understand and describe visual patterns, test ideas, and make decisions using probability. Now we're using all that in one final project. The survey was created by our class and it included many different questions. I focused on 5 that allow me to work with different types of data. Some of these are numerical, like how many hours people sleep or study, or others are categorical, like favorite music genre. In this project, I will show you 1. How I organize and clean the data, what visuals I made and what they show, how I use confidence intervals and hypothesis testing, whether any variables were related, like does drinking coffee mean someone studies more? So for my data, I focus on these 5 survey questions. Do you drink coffee? Is binary. How many hours do you study each week? Quantitative. How many hours do you sleep on school nights? Quantitative. What's your favorite music genre? Categorical. And what's your favorite school subject? Categorical. And also ignore how I say quantitative. I don't know how to say it properly. So these questions help me explore different parts of student life, learning habits, sleeping habits, and even personal preferences. The data needed cleaning before I could use it. Some students entered things like, quote in quotations, like 6 hours or 6 HRS or about 5 instead of just listing the numbers. I went through and standardized these entries. For example, turning 6 hours into 6, just the number 6. I also grouped similar categories like math class, math, and mathematics into just one name, math. This makes the data easier to analyze. The histogram, so the study hours. So this histogram shows how many hours students study per week. Most students reported studying between 5 and 10 hours, which makes sense for high school or college students with a regular workload. A few students study much more, even up to 20 hours more per week. These are outliers, meaning they're far from the typical group. The shape is right skewed, which means most students are on the lower end, and a few pull the distribution to the right. This visual helped me understand how effort is distributed. While some students go above and beyond, most just study moderately. So the frequency table, the music genre. This frequency table is showing what kind of music students enjoy. Rap and pop were the most popular answers. Rock was next, and jazz and classical were chosen by only a few people. Oh, sorry, jazz was next, and then it was rock, then classical. This helps me see what genres most students relate to. Even though this is a fun question, it could also connect to other habits, like maybe music preferences linked to study routines or even their mood. This is a useful frequency table because they make it easy to compare categories side by side. So going on next, I have the pie chart for the favorite subject. This pie chart shows which students' subjects prefer most. Science, English was the top, and then history was next, and then science and math were both on the lower side. Pie charts are great for seeing proportions. We can easily tell which subject is most liked and how each subject compares to the others. It also gives insight into what areas students feel more confident and interested in. So going on next, I have the box plot for sleep hours on school nights. This box plot shows how many hours students sleep during school nights. The median is about 6.5 hours, meaning the half of students sleep more than the half sleeps less. Most people sleep between 6 and 8 hours, but a few students sleep less than 4 hours or even more than 9 hours, and those students are considered outliers. This box plot clearly shows how consistent or inconsistent everyone's sleep is. Sleep is important for health and school performance, so understanding the range was easily useful. So next I have the scatter plot, sleep versus study. Here's a scatter plot that compares hours of sleep and hours of study for each of the students. Each dot represents one person. As you can see, there's a downward trend, and this means students who study more usually sleep less. The line of the best fit slopes downward, and the correlation coefficient, the R value, is about negative 0.45. That's a moderate negative correlation. This doesn't prove cause and effect, it just shows a relationship. It suggests that some students might be trading sleep for more study. So going on next, I have the confidence intervals for the sleep average. I created 2 coefficient intervals to estimate how much sleep students get on school nights. The 90% confidence interval was from 5.9 to 7.1, and the 95 confidence interval was from 5.7 to 7.3. The 95% interval is wider because it's more confident. It gives a bigger range that is more likely to include the true average. This tells me that most students probably sleep only between 5.7 and 7.3 hours based on all of our samples. Confidence intervals help us understand not just what the average is, but how sure we are about that number. So going on next, I have the hypothesis test for coffee versus study. One of the big questions I had was, do students who drink coffee study more than students who don't? To find out, I used a 2-sample t-test to compare the average study hours between the two groups. The null hypothesis, there's no difference in study hours between coffee drinkers and non-coffee drinkers. The alternative hypothesis was coffee drinkers study more. The p-value I got was 0.048, which is just below 0.05, the usual cutoff for significance. This means that I had to reject the null hypothesis and conclude that coffee drinkers do study more based on this sample. This test gave me statistical evidence to support the real connection between coffee and study time. Going on next, I have correlation, sleep versus study. Going back to the sleep and study, I found that the correlation coefficient was about negative 0.45. This is a moderate relationship and shows that the more students study, the less they sleep. It's not perfect, but it shows a real pattern that matches what many of us are experiencing. Correlation helps us describe how two variables move together, even if it doesn't prove one causes the other. So next I have my final thoughts or what I learned. So doing this project really helped me understand what statistics is all about. It's not just about solving problems or memorizing formulas. It's really just about using data to find what's true and what isn't. I learned that cleaning your data is super important. Small errors or messy answers can totally change your results. I also learned that just seeing a difference in averages isn't enough. You need to run a hypothesis test to see if the difference is real. And when things are uncertain, confidence intervals help you